All right, we're recording, and there's sound on the screen. All right. Ladies and gentlemen, tonight we are going to hear a presentation from Professor Jerry Dunifer. Jerry is a professor emeritus at Wayne State University. He was a member of the faculty in the Department of Physics and Astronomy for 35 years before retirement. While active in the department, he served as a professor and associate chair of the department for several years. His research program at Wayne State involved the study of electrical and magnetic properties of high purity metals at a temperature of 1 Kelvin, which is really cold. In Fahrenheit, that's really cold. He also played an active role in the astronomy programs at the department, including the WSU Planetarium and telescopic observing facilities. Since retirement, one of Jerry's many hobbies has been visiting a number of the major and historic astronomy observatories around the world. He's visited dozens of different sites, and he has traveled literally from pole to pole, and many places in between. And one of those places, or several of those places, are what we're going to hear from him tonight. So, without further ado, I give you Professor Jerry Dunifer.
Thank you, Jonathan, and good evening, everybody. So this evening I will tell you some of the highlights of a trip I made down to Chile about a year and a half ago. So I've listed here some of the major things we saw on this trip. We had a tour for one day of the capital city, Santiago. This is a city with a population of more than 6 million people. We visited Cerro Tololo National Astronomy Observatory on the outskirts of the city, and then 4 major observatories: La Silla, Cerro Tololo, Gemini South, and ALMA. ALMA is the Atacama Large Millimeter submillimeter array. And we, in addition to those, although we didn't visit them, we made a couple close approaches to a couple other observatories. SOAR, the Southern Observatory for Astrophysical Research, and the LSST, the Large Synoptic Survey Telescope, which Jim Shedlovsky talked about, I think, a month ago. And we visited a couple other sites of interest. We visited the highest geyser field in the world, and also an area known as the Valley of the Moon. So this is a picture just looking across the street from my house and my neighbor's house on the day I left for the trip. And you can see the winter's still here. We're just a few days from the vernal equinox, so spring is about to approach. Then for going down to the Southern Hemisphere, the seasons will be reversed, and fall will be just a few days away when we arrive down there. So this is the picture out the airplane window. We've flown overnight from Miami, and we're descending now to land in Santiago. I'm sitting on the left side of the plane, so I'm looking out the window towards the east. I can see the Andes out there, and one mountain in particular. This mountain is very prominent. This is the highest mountain in South America, Aconcagua. It is the highest mountain in the Southern Hemisphere. It's the highest mountain in the Western Hemisphere. 22,800 feet above sea level at the summit, but is still more than 6,000 feet shorter than Mount Everest. Okay, so the first full day we had, we get a tour of Santiago. So this is our guide for the city. And I'll just go through a few quick pictures of the city. people on this trip, it was somewhere between 25 and 30, had astronomical t-shirts they were wearing, such as this one here from this member of our group from Arizona. And this is one of the t-shirts worn by the leader of our group. This is Kelly Beatty, who was one of the senior editors at Sky and Telescope magazine. And if you look carefully at the arrangement of the stars, there's something like stars over Katahdin. So who knows what that is?
That's in Maine.
That's right, that's the highest mountain in Maine. Very good. The summit's about a mile above sea level. A few more pictures in Santiago. And then the first observatory we're going to visit is on the outskirts of Santiago. It's the National Astronomy Observatory of Chile, Cerro Tololo. It is owned and operated by the University of Chile, Department of Astronomy. It was established back in 1962. It's east of Santiago at an altitude of about 2,800 feet or so. So there's a number of telescopes up at that observatory. There's an 18-inch Cassegrain reflector, a Japanese Go-To telescope. They have a couple 11-inch refractors and some other telescopes as well. So this is an aerial view showing the hill on which this observatory is located, surrounded by the urban area. And this is a picture looking into the main office. You can see the name, you can look in and see the interior, in the reflection you can see the outside, and a little bit of my reflection taking that picture. There's one of the domes on the site, and another dome. This is Dr. Ismar Santora, retired vascular surgeon who lives in Phoenix. He and I get together from time to time and do some traveling around the world to see some of these telescope observatories. So this is Professor Patricio Rojo from the Department of Astronomy, University of Chile. He is leading our tour. We have a solar telescope. We get to look at the sun for a few minutes. This is one of the 11-inch refractors. One of the other telescopes. And this is our Japanese Go-To telescope. So this is looking from the observatory ground down towards the city. We stayed into the evening where they served us dinner, one of the best meals we had down there. But as you can see, being close to the urban area with 6 million people, there's a lot of light pollution. So the telescopes there are normally used for teaching purposes, not too much research. Okay, now we've traveled about 300 miles north by bus, and we're in La Serena. This is a city of about 200,000 people, and we were based here for a few days since there are a number of observatories in the area which we visited. La Serena. So if you happen to be here on July 2nd of next year, July 2, 2019, you will see a total eclipse of the sun, weather permitting. Okay, La Serena. Okay, so now we get in our bus and we're going to visit our first major observatory. So we're going now to La Silla, and as we get closer to the observatory, you see that the terrain is becoming more and more barren, more and more dry, relatively little vegetation. So the Silla Observatory is operated by ESO, which is the European Southern Observatory, about 100 miles northeast of La Serena. at 7,900 feet. There's a number of telescopes. The main one are the 3.6 meter diameter ESO telescope with HARPS. HARPS is a high accuracy radio velocity planet finder. This is a high precision optical spectrometer. This is the premier exoplanet hunter on Earth. Hunter and finder has found more exoplanets than at any other site. There's also the 3.6 meter new technology telescopes where they try out new technologies before transferring them to other telescopes. And although it's a much smaller telescope, it's 0.6 meters in diameter, or about 24 inches, it has become rather famous in the last couple of years, and that is TRAPPIST, acronym standing for Transiting Planets and Planetesimals Small Telescope. So a couple years ago, they announced the discovery of TRAPPIST-1. This is a small red dwarf star about 40 light years away, and they found around it 7 orbiting terrestrial planets, 3 of which are in the habitable zone. So there was quite a bit written up about this discovery several months ago. Okay, so we're approaching the observatory. It's up on top of this hill. And as we get closer, you can begin to see the observation domes. So this is the exoplanet Hunter, and this is the new technology telescope. So our exoplanet Hunter, you notice there's a walkway around the outside here, and in a couple slides we'll go up there and have a look from that walkway. But first we'll go inside the dome, look at the telescope. So our 3.6 meter diameter mirror is down here. Secondary mirror is up here. And HARPS, this high precision optical spectrometer, is off in another temperature controlled room where people do not leave or enter because everything is very precise and has to be held very stable.
Jerry, is that equatorial mount?
No, it's not an equatorial mount, an all-azimuth mount, as they do with most of the telescopes, the large telescopes,
Just
because they occupy much less space.
almost looks like it could be an equatorial. Thank you.
No, I don't think so. Although, I agree, it does look like it. I'm not 100% positive on that. Okay, so now we're up on that walkway and looking out at some of the other smaller telescopes. This is the new technology telescope that we visit in a couple slides. Just looking around the area, it's quite barren. We're not that far from the Atacama Desert, which is the highest and driest desert in the world. This is Ismar Centaura again. And now standing just outside the new technology telescope, and looking back where we had just been. So, new technology telescope. This person is one of the staff astronomers there, so he gives us a lecture for a few minutes about how the telescope is used. This is the mirror of the telescope that you see right here, edge on. And now we can look down on the polished surface of the mirror. Another view. These things in the background are fans, so they can blow air over the surface and controlling the temperature of the mirror. And the secondary mirror up here. And a couple more views just looking out around the surrounding countryside.
Jerry, what sorts of new technology do they test with the NPP?
Well, quite common nowadays, they use laser beams, which they put out, which they shine out in the direction of that they're looking to excite sodium atoms up there. And by looking at the light coming down, they can by using a flexible secondary mirror, they can pretty much cancel out the effects of distortion due to turbulence in the atmosphere. So that was one that they sort of perfected in that telescope quite some time ago. Okay, and this is TRAPPIST, in the middle dome. Use this one over here, which is used to discover this red dwarf star with 7 orbiting planets. And a few pictures inside the control room. And you see we had a very comfortable temperature of 14.5 Celsius while we were having our tour. Okay, now we're leaving La Silla and we're heading off to the next town where we're going to be staying, Vicuña. Although it's very barren in the general area, there are areas which they irrigate and can grow crops in quite profusion. So this is a vineyard where they're growing grapes. But now we're in Vicuña, and this is kind of interesting. We got in rather late, got into our hotel rooms. We were tired and just sort of wanted to go to bed and sleep. But the mayor of the city insisted that we all get together and come down to City Hall because he wanted to make a presentation to us. So this is the mayor of Vicuña. Standing next to him is Kelly Beatty, senior editor of Sky and Telescope, who is our leader. And on the other side is one of the people in the tour group. He speaks both English and Spanish, so he was our translator. The mayor doesn't speak much English, and Kelly doesn't speak much Spanish, so we used him as our translator. Anyway, the mayor was making a big pitch to us, being representatives of Sky and Telescope. He wanted to set up Vicuña as the astronomy capital of the world. So this is a town of about 25,000 people or so. And it is close to a number of the big observatories. So he made a big push, saying that we should, in Sky and Telescope, for example, try and push the idea that this could become the astronomy capital of the world. I don't think that idea has been pushed too far at this point. So, just a few miles from there is our next major observatory, Cerro Tololo. It's managed by NAOA, the National Optical Astronomy Observatory. It's about 50 miles to the east of La Serena. Altitude is 7,200 feet above sea level. Observations began there in 1965. And the biggest telescope on the site is a 4-meter diameter Blanco Telescope. And of interest, back in 2011, the Nobel Prize in Physics was given for the discovery that the expansion of the universe is in fact accelerating with time. And it turns out that a major portion of the work for that discovery was done on the Blanco Telescope by 2 independent research groups. Okay, so now we're heading for Cerro Tololo. So it's up here on this hill. Getting a little closer. And then we come to a T-junction where we can turn either left or right. So if we turn left, we can go about 3 miles to Cerro Tololo, which is what we do first. But turning to the right takes us to Cerro Pachon, about 9 miles away, where there are 3 observatory sites, one of which we're going to be visiting, namely Gemini South. Also, I should mention that the SST is up there as well. But first, turning left and heading to Cerro Tololo. So this is the dome for the big telescope, the Blanco Telescope. And now we've arrived. And looking out across the countryside again, it looks very barren and dry. We're now looking south, and about 6 miles away is Cerro Pachon, right here. This is actually about 1,700 feet higher in altitude than where we're standing at Cerro Tololo. If you zoom in a bit, you can see there are 3 observatories here. This is Gemini South that we're going to be visiting. Over here is SOAR, and over here is the LSST under construction. But first, Cerro Tololo tour. So this is one of the mascots that came with us. Had this picture taken everywhere we went. First of all, we get a tour of one of the smaller telescopes there. And this was our tour guide. And can you read what his cap says? Michigan State. So you may perhaps have been a student there. Michigan State does have a small observatory dome on that site, but not this particular one. So here we are listening with rapt attention to him. This is the big one, the Blanco Telescope, 4-meter diameter. They have it tipped over on its side because they're doing some work on it. And it is so big, and you can't get very far away from it being inside the dome. It's pretty much impossible to get a picture of the whole thing at once. So one can just take pictures of bits and pieces of it. And here is one of the technicians acknowledging that I'm taking this picture. Okay, so now we've come down from Cerro Tololo. We're back at this T-junction, and I'm standing here by that same sign, and you can see behind me SOAR, Gemini, and LSST. And we have a nice viewing site here with 3 viewing tubes pointed at each of the individual observatories up there. And there's also this bronze sign that was there. This has been named Vista Sidney Wolf. And it says, the beautiful view is dedicated in the honor of Dr. Sidney Wolf, whose vision and leadership as director of NOAO, director of Gemini, and president of the SOAR board and the LSST Corporation were critically important in the establishment of the facilities you see up on Cerro Pachon. So I should mention that Sidney Wolf is an American astrophysicist. She was the first woman in the United States to head a major astronomical observatory, and she played a major role in the establishment of 6 major observatories around the world. She was also the co-author of an astronomy textbook named Astronomy, which we used down at Wayne State University for a few years. If you're familiar with it, there were 3 authors, Andrew Fracknoy, David Morrison, and Sidney Wolf. So anyway, this is her vista point. And a couple more views of Vista Wolf. Okay, a few words about Gemini South. It's again situated on Cerro Pachon, 6 miles south of Cerro Tololo, altitude 8,900 feet above sea level. It has a mirror which is more than twice the diameter at Cerro Tololo. It's the twin of Gemini North, which is on Hawaii, on Mauna Kea, at close to 14,000 feet. And I have been to this one as well. They do a number of studies there: solar system, exoplanets, formation, evolution, structure, and dynamics of galaxies, black holes, distant quasars, structure of the universe on the largest scales. Of course, this type of work is done at most of these major observatories that we were visiting. Adjacent is SOAR, the Southern Astrophysical Research Telescope, 4.1 meter diameter mirror, and also, as I said, it's adjacent to the LSST, which will have an 8.4 meter diameter mirror. So now we're in the bus driving up. They're getting a little bit closer. You can see the 3 observatories a little better. And now we're passing close to LSST, and you see we have a couple construction cranes up there. And finally, we're here at Gemini. So, looking about a quarter mile away, this is the dome for SOAR. And that is the end of my first half. Let me see if I can get the second half set up. Oh, okay, so that was pretty easy to do. Okay, now from Gemini, we're looking back at Cerro Tololo, where we've been earlier in the day. So this is the dome for the Blanco Telescope, and you can see the road that we had taken between the two observing sites. It's 6 miles in a straight line, 12 miles by road. And a little closer, looking again at Cerro Tololo. And now we're in the observing dome for Gemini. And now we get the date. So now it is Wednesday, March the 22nd, 2017. So I think now it's spring in the Northern Hemisphere and fall in the Southern Hemisphere. Time is 2:38 p.m. in our location in Chile, and 7 hours earlier on Mauna Kea in Hawaii. So again, it's difficult to get the whole telescope in one shot. That's a secondary mirror at the top. This is down the base. The entire floor area in here rotates along with the telescope when they are pointing it. Another view of a portion of the telescope. And the large 8.2 diameter mirror is behind these shutters. And now outside we can look back towards the LSST and see the construction which is going on. So 2022 is when this site should be in full operation. So now we're going to take a little break from looking at telescopes. We're going to go down to visit this site where they produce a very popular drink in Chile known as pisco. Company is Capel, they make pisco, which starts out, they make it from grapes, starts out pretty much like wine, but then they distill the wine to increase the alcohol content up to 30-40%, something like that. And they make a very popular drink known as a pisco sour. Now I don't particularly like alcoholic beverages, but I've had a couple of pisco sours and they weren't that bad actually. And here's our mascot again. So we were taken on a tour of the facilities, explaining some detail how they make it. These are the grapes that they use. And then we had a tasting room where we got to sample the product. That was our tasting room. Okay, next, we've taken a flight. We've traveled by airplane about 700 miles to the north into the Atacama Desert, and we're on our way now to visit ALMA. And so driving across a portion of the Atacama Desert, this is a wind farm. This is a new bus that we're in. So we've stopped after a couple hours of driving to stretch our legs. There's a very prominent volcanic peak, which I'll say a few words about in another few slides.
Pretty impressive.
Okay, so now we're in the small town, population about 4,000, of San Pedro De Atacama. This is Craig Nelson, who lives near Portland, Oregon. He and I had tentative plans to get together next year and visit LIGO up in Hanford, Washington. So we'll see how that goes. So this is only 30 miles from ALMA, so we're staying there for about 3 nights or so. Because ALMA is so close, astronomy is very popular in this little town, and there's a number of shops which advertise astronomy tours, or over here they talk about you can get a tour of a volcano.
Is that a chunk taken out of that old Celestron?
Is that a what?
Chunk taken out of
Chunk? Looks like it.
Maybe counterweight.
Yeah, I mean, you're talking about right up here?
it? Yeah, right up there.
Well, look, yeah, it looks like a piece has been broken out. I don't recall from being there the details of what we saw.
Been there for a while.
But anyway, astronomy tours are quite popular. And they had some pretty good restaurants in the town. So here's another place advertising astronomy tours, astronomy classes. And another place, tour Astronomical. Okay, and now we're in the bus and are on our way to visit ALMA. So here's that prominent volcanic peak I mentioned before. It is named Lycankabur. It is at a summit 19,400 feet above sea level. So that's about 500 feet higher than any of the highest mountains in the U.S. outside of Alaska. So this, in fact, is quite tall. There is, in fact, a small crater at the top of the lake in it, which is the highest and one of the highest lakes in the world. So, ALMA, the Atacama Large Millimeter and submillimeter array. It's operated by a collection of different countries: European Southern Observatory, United States, National Science Foundation, Japan, Canada, Taiwan, Korea, and Chile. It is an array of 66 telescopes, all connected together, either 39 feet in diameter, most of them are, but some a little bit smaller at 23 feet. It's located up on the Chattanooga Plateau, 16,500 feet above sea level. That's very high, and they didn't actually take us up there to see the dishes, because at that altitude, people start dying from hypoxia if you don't have supplementary oxygen. So they didn't take us up. Instead, we were at the operations facility, which is about 7,000 feet lower. So we're about 600 miles north of La Serena. This is the most expensive ground-based telescope in the world, $1.4 billion US. It studies wavelengths from about 9.6 millimeters down to 0.3 millimeters. And if you like frequency better, that's 31 to 1,000 gigahertz. Electromagnetic waves of that wavelength of frequency are strongly absorbed by water vapor in the atmosphere. So they need a site which is exceptionally dry. So the Atacama Desert in general is very dry. And up at 16,500 feet, it's extremely dry, which is why that particular site was chosen. The spatial resolution is 10 milliarc seconds, 100 of 1 arc second. So that's 10 times better than the VLA, the Very Large Array in New Mexico, and it's 5 times better than the Hubble Space Telescope. And a little more information. It's the largest radio telescope in the world. The 66 dishes can be spread out over an area with a diameter of about 16 kilometers, or 10 miles. The detectors themselves of the millimeter waves operate just 4 kelvins, 4 degrees above absolute zero, and has been fully operational for about the past 5.5 years. So the tour we had was at the Operations Support Facility at an altitude of 9,500 feet, where people do not generally die from hypoxia. So the individual antennas are 115 tons, and they are moved around by heavy haulers, which have been built in Germany. They go by the names of Otto and Lori. There are two of them. And I'll show you pictures in a few slides. So they study a number of things there, forming evolving planetary systems, complex molecules and nebulae, stars, galaxies, regions around black holes, and so forth. So, we're now approaching ALMA, and this sign tells us what the speed limit is. So let's see, we're a light vehicle, we can travel at 60 kilometers per hour, 36 miles an hour top speed. Use of seat belts is mandatory. Must turn the headlights on, also mandatory. We gotta obey the directions of the guards. So this is the entry to the site. These are some wild burrows or something like that. Again, our 19,000 foot volcano over here. And this is the main site where most of the people work. And again, here's another, this is the same guy we saw before from Arizona, Saguaro Astronomy Club. You recognize the constellation on the back of his t-shirt?
Scorpio.
Scorpio, yes, the Scorpion. This was our local astronomer guide. And I just took this picture. I like the sunlight shining through the slots in the roof, the pattern produced on the floor. We're now inside the facilities, and we're looking off in the direction of where the radio dishes are. And it's actually some distance away, like about 15 miles or so. If you follow along this road and climb up several thousand feet to the plateau. So inside the control room. Now this is an American astronomer from a university. I wrote down his name on a piece of paper. I lost the piece of paper. I don't remember his name or the university. Does anybody recognize that astronomer?
What's his name?
I will have to look further into that. But anyway, he spent a few minutes describing the facility and the specific research he was doing at that site. He put hard hats on, took us outside, and first of all saw these heavy haulers that haul the telescopes around. This is where the driver sits. It's a hermetically sealed cage that he's in with supplemental oxygen. If you cut up the wheels, there are 28 wheels. These movers are 130 tons in weight. They have a maximum speed of 7 miles per hour when they're hauling a telescope.
How much does each one of the telescopes weigh approximately?
Now, the telescopes are 113 tons. The big ones are 113 tons. So this is the back of one of the big telescopes. A side view of the telescope and a view of the telescope from the front. And although we didn't go up there, here are a few pictures up on the plane at 16,500 feet elevation. And this is an artist's rendering of what they look like. Telescopes can all be moved around. They can be clustered close together to see a larger region of the sky. They can be moved far apart to get better resolution in a small area of the sky. And again, they can be spread out over an area about 16 kilometers in diameter.
Jerry?
Here's a representation of one of the haulers moving a telescope.
Jerry, the actual direction of each telescope is remotely controlled?
This is all pretty much remotely controlled from down where we had our tour.
But the actual arrangement has to be manually driven by somebody.
When they move the telescopes, they have to go up and move them manually. But once they are in place, then they can all be controlled remotely. Okay, another picture. If you look carefully, you can see the large Magellanic Cloud and the small Magellanic Cloud.
Is that one of the smaller telescopes on the left?
What are we looking at here? Might be. Probably, yeah, probably is. And then we took a couple side trips just to see some interesting things in Chile. So this is either the highest geyser field in Southern Hemisphere or the highest in the world. I've seen both claims. Anyway, it's known as Altashio. It covers approximately 4 square miles. There's more than 80 active geysers which are there. It's up high. We're at 14,200 feet above sea level. The geysers are not very high. They're typically 2 or 3 feet high. The very highest one I saw was probably 6, and the highest one they had listed was 20 feet. So we had to get up early in the morning while it was still dark and drive about 50 miles up to the site from San Pedro. They wanted us to get there before the sun came up because that was supposed to be the most spectacular. So there's one of the geysers, probably a couple feet high. And here's where the water's not too hot or too cold, it's just right. So we were invited to jump in and go swimming. None of our party did. And now you see the sun has come up. Now we're standing here 14,200 feet above sea level, which is almost as high as the highest mountains in the United States, outside of Alaska. But yet you can see mountain peaks all around, which are thousands of feet higher than we are. Which, at least to me, was quite impressive. So they fed us breakfast up there. And we got back in the bus, and then we drove back to San Pedro, stopping a few places along the way to see the sights and the animals. And then the last place we visited that was officially on the list of sites to be seen was Valley of the Moon Valley, which has a number of rock and sand formations produced by water and wind. We spent a few hours walking through this. This is Kelly Beatty in one of his astronomical t-shirts. So this is, it looks like snow. This is not snow, this is salt. Valley of the Moon. This is only about 8 miles to the west of San Pedro. Then we discovered a cavern. And we came out on the other side. There are people exiting the cavern. And then, the day that we flew home, we flew back to Santiago. We arrived fairly early in the morning. And we all had flights which were either in the late afternoon or evening, so we had several hours to kill. And so the president of our tour company, this is Spears Travel, the president is Gary Spears, who was there with us, apparently on his own, hired a bus for us, took us an hour's drive from the airport down to see an organic vineyard, which we toured. Very pleasant place, much better than waiting at the airport. So we had explanations to how they can grow the grapes organically without the use of pesticides. And then we had the tasting room. Yeah, wine tasting. So in this case, we sat down, we had 4 glasses of wine, 4 different kinds of wine, 4 different kinds of cheese to go with each of the wines. And they had bottles that one could buy and take home, of course. Okay, so that brings me to the end of my talk. Thank you very much for your attention. Yes.
Any trouble breathing at higher altitudes?
The only place that it was really noticeable was at the geyser field, which is some 14,000 feet above sea level. The other highest place was at the ALMA Operations Center, which was 9,500 feet. Nobody seemed to have problems there.
And one more question, what was that wine, the earlier wine?
What about
What was it called?
the wine they distill? Pisco, P-I-S-C-O.
Did you get that locally?
Say again?
How do you get your hands on that? Can you get it here locally?
Yes.
I don't, yeah, can you? I don't know, I'm trying by again.
It's trendy now.
We'll mount an expedition.
Okay. So, yeah,
Right.
Jim.
I don't know if they mentioned to you the Cerro Tololo,
Yeah,
where the LSSP and
Yes.
Gemini South and
Right.
that all of those observatories have an agreement where they operate with the same maintenance people and utilities and so on and so forth, under the auspices of ARA.
okay,
And
yes,
so-
yeah, no, that was not mentioned to
And
us.
so they have a connection to the Cranbrook Institute of Science,
Do they?
because Robert McMath was the first chairman of ARA when it was formed,
Okay.
and he built the original drive for the telescope upstairs,
Oh,
and designed this building.
oh,
and-
well, that's extremely interesting. And so the influence has spread around the world.
Michigan has a presence in Chile.
That's right. Presence, yes, back there?
How are the radio telescopes powered?
How are they powered? Where do they get their electrical energy? We didn't actually go up to see. I almost certain, well, can't be sure. They may have electrical generators up there to produce the electricity. Or perhaps they bring it in from further down. I don't know the answer.
Okay.
I know at the South Pole they generate their electricity right there on site. Yeah, I don't recall seeing any pictures showing generating facilities up on the plateau.
Probably some solar stuff too, I'm sure, I would think. Who knows?
I'm not sure.
Just a guess.
You got other questions? Yes?
Does it ever rain there?
In place, up on the plateau, you see snow certain times of the year. The Atacama Desert is the driest desert in the world. And they report that there are places in the desert where it has not rained for more than a century. So there are extremely dry places, but there are other places that get some water. Yes, Jim, again?
Did they explain how, I'm sorry,
We got one in the way back.
How long was the total trip?
We were probably away about 12 days, something like that. Yes, and Jim?
the geysers up at 14,000 feet.
Yeah.
Kind of amazing. Think of the head of water you had today. Any explanation about where the pressure came?
Well, there are mountains around there which are higher by
Yeah,
some thousands of feet.
Yeah, okay. I guess that would.
Specific
Yeah,
ring of
but again, they don't have real high geysers. They're all reasonably short. Yes?
Did you have empanadas?
Did I have a what?
Empanadas.
Bananas?
Empanadas.
Empanadas.
They are very good in Chile.
Not that I remember, no.
Like a meat pie.
Meat,
Yeah, yeah.
chicken or gravy.
Yeah.
Yeah, they
not
have
that
those
I
in
recall.
Australia.
May have.
They're not called empanadas.
Dale?
They're called meat pies.
Do they have, did you hear anything about controlling the lights that small nearby towns use at night to not interfere with the observatories?
No. Most of the observatories are fairly remote from town. There's some small towns, but nothing very major close to the observing sites, the optical observing sites. And nobody said anything about the Yes.
Are any of the sites or the high elevation places sacred? Do you know if there are any Indian?
Yeah, according to the native populations. I think that may be the case. Yeah, in
Are
fact,
they upsetting any gods by building these things up there on the mountains?
not that I'm aware of, but yeah, I think that volcano I pointed out, the 19,400 foot, I think that may be sacred to certain of the native tribes.
The cost of the tour?
What does it cost?
You have the right to read style.
I don't recall the exact cost, a few $1,000s, I guess.
How many?
A few? I don't recall the exact. Very cheap compared to going to the South Pole.
Or the moon, for that.
I was nearby the Aconcagua.
Aconcagua, yes.
I drove a little Fiat, like you see this model today, small Fiat.
Yeah,
And when we come up to Cristo Redentor, they go way high up,
yes.
no oxygen, we got to push the Fiat.
Yeah. Was there a road that you
So
were?
we pushed maybe 200 yards or something
Yeah.
like that. It didn't work anymore, you know.
Okay.
Now, when we come down,
Bolivia, yeah.
we were lucky the street go wrong and the plow left the soil like this, you know. When you come down at night for ice, and the field was, I couldn't drive it, I went to that soil, otherwise I go down. I don't know, I was a little wild there.
Yeah, well, good thing you're still here.
And when you are up in the top, in front of Aconcagua, you can walk. You go slow. If you walk hard,
Yeah,
really.
right. Well, when I was down at the South Pole, one of our guides down there, Belen, was from Peru.
Yeah.
She's a mountain climber, and she's climbed that mountain. She said it's not technically difficult. The main problem is very little oxygen up there. So oxygen stock.
You got to probably wear it with you.
Yeah, I don't know if she did that or not. They may have just gone up very slowly to acclimatize. But that was the main problem with the oxygen.
Another thing is very interesting. When you come down to the mountain, you got 365 curves.
Yeah,
365 curves.
for every day of the year.
You know, I was correct. I don't know, maybe
You probably take a year off your life.
Yeah, probably.
365.
Yeah, further back.
Curves.
Was there any discussion on some of the construction challenges at 16,000 plus feet?
Oh, God.
A lot of the construction people were local people who lived at fairly high altitude and were able to perform better than you or I would. But a lot of them also were using supplementary oxygen.
Of course.
While they were up there working. Jonathan?
Was there any discussion, is there any sort of contention between local needs and the needs of the scientists? The way you sort of see in Hawaii or in some other places where either there is, a sacred element to the geography or simply, its resources going to outsiders rather than to the local economy?
Yeah, I don't know the answer to that question.
More in Bolivia.
Nothing was brought up on our tours. That was not discussed.
Much more in Bolivia than Chile, I understand.
Yeah.
Bolivia has
Well,
a lot of-
we were not in Bolivia, but we were very close to
You were in the
Bolivia.
Atacama.
Close to one.
Yeah. The geyser field was just, I don't know, 3, 4, 5 miles of the
Right.
Bolivian border.
That's in the Atacama.
Well, the Atacama Desert comes right up to the border. Yeah. Jonathan?
How doable do you think, how difficult do you think it would be to do that sort of trip on your own? Like, I imagine it would be impossible to get into many of the observatories for a trip. Like, how many of these places do you have to be part of a large organized trip to see?
Spears does a lot of traveling down there.
I would guess that probably you can't get too far on your own.
Yeah.
At least to get into the big observatories. I know we tried to get into Gemini South on my first trip to Chile, and they had promised that they would give us a tour, and then they canceled at the last minute because Spears Travel Service, which we were using then, was a for-profit travel agency, and because of that, they said they wouldn't let us in. Even though we were all Blue Sky and Telescope magazine, that wasn't sufficient reason. So I think individually probably would be fairly difficult.